Student t-distribution. The t-distribution is a symmetric distribution that is peaked at the center and approaches the horizontal axis the further from the center of the distribution the t-value is. For each degree of freedom, there is a different t-distribution. For small degrees of freedom, the t-distribution is considerably more varied than is the normal distribution. But as the degrees of freedom increases, the t-distribution approaches the normal distribution. When there are more than 30 degrees of freedom, the normal rather than t-distribution is used. Okay, when do we use t-distribution? It is commonly used when n is less than 30 degrees. Or I should say 30. It's just the same. But if it's greater than 30, then we can make use of the normal. The t-distribution is often required when the sample size is small. Small random samples produce statistics which can be quite variable from sample to sample. When sample sizes are larger, many statistics are normally distributed, but such is not the case for smaller sample sizes. In particular, the mean of a random sample from a normally distributed population has the t-distribution. For some other statistics that do not have an exact t-distribution, the t-distribution may provide quite a close approximation to the sampling distribution when the sample size is small. So from t-distribution, we can make use t if the sample is small, and we can make use of z as n increases. So look at this representation. So if the degrees of freedom is 5, then the graph will look like this. If the degrees of freedom is 13, then your graph will look like this. So if it is greater than 13, or look at this graph, it pertains to the standard normal, and the t-distributions are bell-shaped and symmetric, but have fatter tails than the normal. So what have you noticed on the representations? So the lesser the degrees of freedom, the fatter the tails are. How can we determine the t given or t value given a specific area or confidence level and or alpha? So you have to look at the study below and you have to pay attention to the result on how the t value was determined. So given is 95% confidence level with n is equal to 12. So how can we determine the t value? So our solution is we are looking for the middle 95% area under t distribution with n minus 1 is equal to 12 minus 1 is equal to 11. So this is how you're going to get your degrees of freedom. Degrees of freedom is equal to n minus 1. So here, our n is 12 minus 1 and our degrees of freedom is 11. By the way, if you're going to ask me about the degrees of freedom, this is the definition of degrees of freedom. It indicates the number of independent variables that can vary in an analysis without breaking any constraints. It is an essential idea that appears in many contexts throughout statistics, including hypothesis tests, probability distributions, and regression analysis. Since 90% confidence level, then alpha is 0.05 and alpha divided by 2 is 0.025. Using the attached table of critical values of t-distribution, look for the intersection of degrees of freedom is equal to 11 row and 0.025 column. So it indicates that we're gonna divide our alpha into 2 for two-tailed. So we have 0.05 divided by 2 is 0.025. So you're gonna look for 0.025, and since our degrees of freedom of 11 and their point of intersection, as you have noticed here, so this is going to be your, or its area, or the 95% area under the t-distribution. So our interpretation is that the intersection is at 2.201, thus the t-value is 2.201. This means that the shaded area would begin at negative 2.201 on the left up to 2.201 on the right. So if we're gonna draw, okay, so if we're gonna draw a normal curve here, so no need. You're gonna start at negative, suppose this is our mean, negative 2.201 up to 2.2 0.201 at the right. So your graph will look like this one. So if you're gonna graph it. Okay? So the shaded part will be up to this part and up to this point. Then just shade it. So that's gonna be the area pertaining to the degrees of freedom of 11 and its alpha at 0.025. So how can we determine the probability of t? So we have our first example, the probability of from negative 0.025 up to 0.05. The probability means how are we going, I'm gonna show you how to get your probability. So suppose that the area under the normal curve before, it is equal to 1, right? So here, if we're gonna start at 0.025 and from up to 0.05, you just have to subtract this one first, 0.025, then subtract 0.025 to get its probability. And that's gonna be 0.925 or 92.5%. The probability from t sub 0.025 less than t sub 0.05 is 0.925 or 92.5%. Meaning, if we have here your representation and then you're gonna start at negative 0.025 up to t sub 0.05. I'm not gonna show you how on our representation, but I'm just gonna make you realize that it's just that you have to subtract 0.05 and 0.025 to get its probability, which is 0.925. So determine the t corresponding for each level to each level of confidence in degrees of freedom. 95% confidence level and n is equal to 17. So first, we have degrees of freedom. N is equal to 17. Its degrees of freedom will be 16, right? N minus 1. In here, so we have degrees of freedom is 27. Just remember that we have 95%. So we look for t is equal to 2.120. T is equal to 2.052. Let's see how did we get those two. This is our sample table. So our n is 17. And then we're gonna look for 95% confidence level. So suppose this is our table. You can easily determine its degrees of freedom, which is 17. But we're gonna look for the 95 confidence level. Just look at the bottom part of your table and have your 95 degrees. And then if your degrees of freedom is 16, 95% and 16, its point of intersection will be 2.120. That's why our answer here is 2.120. So n is 27. And then we have to look. Its answer is 2.052. Let's see. So 27. This one. And 95 degrees. 95 confidence level. So 2.052. Correct. Okay. So in here, our alpha is 10%. And n is equal to 9. So on our table, so look at if n is 9, so you're gonna look for 8. And then this one, 0.10. Then its point of intersection is 1.860. Okay, so if our alpha is 10%, its confidence level is, if our alpha is 0.10, its confidence level is 0.90. Okay, and if our n is 23, its degrees of freedom is 22, and then its confidence level is again 90. So it's going to be 1.1717. Here, so you just have to subtract 1 minus 0.05 minus 0.05. The answer will be 0.90. 1 minus 0.025 minus 0.01. The answer is 0.875. So that's with number 3. So all you have to do now for independent practice is just answer if our confidence level is 99% and our N is 15. So you have to make use of your T table as your reference. So that's it. No need to answer explore activity. Thank you for listening and God bless you all.